All right, let's dive into this incredible story of how physicists are using the absolute weirdest parts of quantum mechanics to build the most sensitive instruments humanity has ever conceived. We're going to see how they are quite literally cheating the laws of physics to get a brand new look at the universe. But first, to really appreciate how brilliant the solution is, you have to understand the enormous challenge scientists were facing. They didn't just run into a technical glitch, they slammed right into a fundamental wall built into the fabric of reality. So what you're looking at here is a gravitational wave detector. It's a gigantic laser setup, and its whole job is to feel the tiniest, faintest ripples in space-time itself, maybe from something like two black holes smashing into each other a billion light years from here. I mean, we are talking about measuring a change in distance smaller than an atomic nucleus over miles. It's just mind-boggling. Now, to even attempt this, these machines have been engineered to the absolute ragged edge of precision. The lasers have to be perfectly stable, the mirrors are smoother than anything you can imagine, and the whole setup is shielded from even the slightest earthly vibration. But here's the thing. Even with all that genius engineering, they hit a hard stop. And this wasn't a problem you could solve with a better material or a smarter design. No, this was a roadblock put there by the fundamental laws of quantum physics. So what is this quantum wall? Well, it all comes down to the nature of light itself and the tiny particles that it's made of, photons. It's called quantum shot noise. And honestly, the best way to think about it is like the static you get on an old radio when you're not quite on the station. It's this constant shh. Because light is made of individual photons and they hit the detector randomly, they create this unavoidable, fuzzy background noise. And this picture just shows you the problem perfectly. On the left, that tiny little signal, that's our gravitational wave. It's completely swallowed up. It's just lost in that random quantum static from the laser light. You can't see it, you can't measure it, it's just gone. So, to get past this quantum wall and actually hear those faint whispers from the cosmos, scientists needed a truly radical idea. They had to find a way to cleverly bend or even cheat the very rules of quantum mechanics that were causing all the trouble. And they found it. The solution came from this really bizarre, purely quantum state of light that you'd never see in everyday life. It's called squeezed light. You see, squeezed light is all about manipulating the uncertainty that's baked into the quantum world. This gets right to the heart of Heisenberg's uncertainty principle. You know, the rule that says you can't know everything about a particle perfectly all at once. If you measure its position more precisely, its momentum gets fuzzier, and vice versa. There's always a trade-off. Okay, so imagine the quantum noise in a normal laser beam is like this fuzzy circle. The uncertainty, the fuzziness, is the same in all directions, and you can't make that circle any smaller. That's a fundamental limit set by Heisenberg. Now, check this out. This is what squeezing does. The best analogy is a water balloon. You can't reduce the total amount of water in it, right? But you can squeeze it, making it thinner in the middle while it bulges out on the ends. Squeezed light does exactly that to quantum uncertainty. Scientists basically dial down the uncertainty in the part of the light they need for their measurement, and who cares if it gets bigger somewhere else they don't look? It's a brilliant workaround. So this all sounds like some wild theory from a physics textbook, right? Well, what's so amazing is that it's not. This is real, it's working right now, and the results are incredible. And this isn't some newfangled experiment that just started last week. The GEO600 detector over in Germany has been using squeezed light to boost its senses for over 7 years now. This is proven, road-tested technology. So the bottom line is this. This quantum trick isn't just a cool party trick. It's a critical tool that is helping us open an entirely new field of astronomy. It's letting us listen to the universe in a way we never could before. And the payoff is enormous. By turning down that quantum static, we can hear those incredibly faint signals from colliding black holes and neutron stars from much, much deeper in space. We're seeing cosmic events that were totally invisible to us before, drowned out by the noise. But hold on, because the story doesn't stop here. It gets even weirder and way cooler. Squeezing light is really just a beginning, and it's prying open the door to some truly mind-bending physics. What scientists are exploring now is something called two-mode squeezed states, and that is basically a form of quantum entanglement. Yep, the very same thing Einstein famously called spooky action at a distance. Think about it. We're talking about creating two separate beams of light that are fundamentally linked. A measurement on one beam instantly, and I mean instantly, affects the other one, even if they're separated by miles. The potential for building even more powerful sensors with this is just wow. So when you step back, it's pretty amazing. We ran into a hard limit set by the laws of quantum physics, and the only way to get past it was to dive even deeper into the strangeness of those very same laws. It really makes you wonder, doesn't it? What other impossible things are out there, just waiting for us to unlock them with a little bit of quantum weirdness?